Hi everyone. Let's take a look at the following example. Given that the magnitude of V equal to 6, determine the following. Part A, the magnitude of 2 times vector V. Again, if you think about 2, which is inside the magnitude symbol, you can bring it to the front. So this becomes 2 times the magnitude of V. Since this is given to be 6, 2 times 6 equals to 12. Part B, the magnitude of negative of vector V. Now, this is one of the most common mistakes that I see on a given assessment of learning. So remember, when you're looking at the magnitude, you're looking for the positive outcome. It's going to be a length. So even though the vector could be negative, which means it's the opposite vector of the original vector, however, this is equal to the magnitude of V. So the answer is going to be 6. Part C, the magnitude of half times vector V. Just like part A, bring half to the front, multiply this by vector V, which means it's going to be half times 6, which equals to 3. Now at this point, I would like you to press pause, try D, E, and F. When you press play again, I'll be here. Welcome back, everybody. Again, if you look at part D, you're looking for the magnitude of negative 6 times vector V. Remember, magnitude must be positive. So this is the same as taking 6 times the magnitude of V, which is 6 times 6, which equals to, let's zoom up for you, 36. Part E, the magnitude of V, or vector V, plus vector V. This equals to the magnitude of 2 times vector V, which is exactly what we did from part A. So the final answer is going to be 2 times vector V, or the magnitude of vector V, which is 2 times 6, which equals to 12. Last but not least, part F, the magnitude of vector V minus itself. And again, when you think about any vector, adding the negative of its own vector, or vector V minus vector V, that's going to equal to a 0 vector. And of course, the magnitude of a 0 vector equals to 0. I hope this makes sense.